We're looking at the network logic diagram that we completed in class for the steel frame. And in this one we have the finish-to-finish relationships that we were looking at rather than the start-to-start relationships, because we recognized that those start-to-start relationships caused an impossible situation in terms of the overlapping of the work. I've gone ahead and I've completed the forward pass and I've completed the backward pass. So on the forward pass we carried the larger numbers forward. In situations where we had a finish to finish, for example, I took 21 plus 2 gave me 23 minus the 6 to get 17 as a start date. Then in the subsequent activity, 23 plus 2 gave me 25. Then I subtracted 4 to get 21 as a start date. And here, 25 plus 2 gave me 27, minus 5 is 22. That was bigger than the 6 that was coming in from the other activity. Down below, I had 21 plus 2 gave me 23, and then I did the subtraction to get the start date. I did this again, 23 plus 2 gave me 25 to finish, subtracted to get the start date, and here this was a start to start, so I took 19 plus 3 to get a start date, and then completed the task math. In so doing, I ended up with 31 days, so this is a 31-day project. I carried the 31 down, and then I did the backward pass, carrying the smaller numbers forward when we had multiple activities. And to do that backwards, I did things like on a finish to finish, 27 minus 2 gives me 25 in the finish box. Then I subtracted the forward duration to get the start date. Here I had a similar finish to finish of plus 2. So on the backward pass, that's taking the finish date of 25 minus 2 into the finish box for 23. Then I can complete the math in the start box for the late start. Now, the question came up, and this is the point of our video here, is what about float? And you can see here that we have a central box for total float, okay? And that total float is taking the late start subtracted from the late finish, as we've got here, or the early start taken from the early finish. In either case, it's a subtraction problem from the upper subtracted from the lower. These should result in the same total. In this case, we've got 16 days of total float with that activity. Along here, this is critical, so 1 minus 1, 21 from 21, etc. All of these are resulting in a total float of 0 because those tasks are critical. And then down here, we have 23 minus from 26 is 3. And I have 3 in each of those boxes. And that's the total float. Now, what types of float do we have? Up here, this is 16 days of independent float because the task is off by itself, directly off of the critical path, and then right back onto the critical path all alone. So all 16 days are either devoted to shop drawings or no one else uses those days. Down here, we have a different story because we have 3 tasks in a row that come off the critical path. They have 3 days and they go back. This is why we call it shared. Most likely this float is shared between these because look, if they're on time, 23 plus 2 means they are finished on day 25. If they were to finish on day 24 instead of day 23, 24 plus 2 would mean they'd be done with this next activity on day 26. That's a day late. And I can see that each of these 3 days directly impact the 3 days for the following activity. The same holds true between panels and glazing. If they're done on time, 25 plus 3 means these guys would be done on time for day 27. And that's fine. But if these guys are a day late and they start on day 26, 26 plus 3 would be 28. That's putting these guys a day late also. So this is shared float, and we put it in the SF box here. And only when it gets to install glazing could it possibly be considered free, because once it gets to them, it's an either use it or lose it situation. So you could say, in effect, that this is free if it gets here. Okay, the rest of this is shared on this string, right? Hope that helps you guys out.